Hey guys, today's lesson is going to be very heavy on proofs and constructions. So you're going to need your compass and straight edge, and just be in the frame of mind to understand that you're really going to need to focus on this lesson, okay, and take really good notes. You probably will have to pause and rewind, okay. This is one of those things that it's really labor intensive, so you need to make sure that you're with me 100%. If you are not in a quiet place or not at a good time to watch the video, then just come back to it later, okay? Before we get started too much, I want to talk about what a compass is for, okay? When I open my compass to a certain width, it stays that width until I change it, okay? That's why I can draw a circle, because a circle is all of the points that are equidistant from the center, okay? Using a compass, we can mark, like for example, in this right here, we are copying the line segment, okay? So by construction, we can say that this segment is the same length as the black one right here, okay? Now, what we have here is that we have some markings, blue, red, dotted lines. Okay, first off, these blue arcs are arcs created from point A and point B. And this red line was drawn through points C and D, or my intersection of the arcs. So what's happening here is that this is going to be the perpendicular bisector. Now we know that this red line cuts line segment AB in half, but we are actually going to prove it this time. Now the reason we did not prove this ahead of time is because I wanted to break you guys into easier proofs before we hit the hard and heavy proofs, okay? So first things first, okay, I want you to draw AC, BC, AD, and BD, okay? So that's going to be your step one, is to draw AC, BC, AD, and BD. Okay, and the reason I can do that is because there's exactly 1 point between two lines. So there's exactly one line, between 2 points. Alright, now I can say that AC and AD are equal measures because that is the definition of the compass. I set it to a certain width. Okay, and then I did it from point P without changing the compass width, so that means that BC and BD are also the same length as AC and AD. So I need to write that here, that AC is congruent to BC, which is congruent to AD, which is congruent to BD. Okay? And that's going to be because I set my compass to that setting. So I'm going to say same compass setting. I also know that line CD is congruent to itself by the reflexive property. So what I can say here, I'm going to scroll down just a little bit, is I can say that triangle ACD is congruent to triangle BCD, and the reason for that is side, side, side. And we use the information from steps 2 and steps 3. Okay, so you understand right now that we have proved these two triangles here congruent. So this one is congruent to this one. Okay? Alright, now why did we prove those two triangles congruent? The reason is because I want to show that angle ACD and angle BCD are congruent. Now I can say that is true because of corresponding parts of congruent triangles must be congruent. So angle ACD is congruent to angle BCD by corresponding parts of congruent triangles are congruent. I also know that line CM is equal to itself by the reflexive property. Okay, so you see what's happening here is I'm looking at these two triangles now. This one and this one. And right now I have side, angle, side, and I can prove those two triangles congruent. So first let's go ahead and say that CM is congruent to CM by the reflexive property. And that means that the two triangles must be congruent. So triangle ACM is congruent to triangle BCM by side, angle, side. And in this case, we used steps 2, 5, and 6. So what that means for us is that we know that line AM is congruent to line BM by the corresponding parts of congruent triangles are congruent. Since AM must be congruent to BM, then M has to be the midpoint of AB. So we say M is the midpoint of AB. And that is the definition of a midpoint. Now remember, when you get to what you're trying to prove, that belongs in the last statement. So we were trying to prove that M was the midpoint of AB. We did that, and so we are finished. Alright, so for our second proof, this time, instead of proving that M is the midpoint, we need to prove that line CD is a perpendicular bisector, meaning it meets at a right angle with line AB. Now this proof actually starts exactly the same way as our previous proof, okay? So what we proved here is, where the proof ends, is that we proved that this triangle ACM is congruent to triangle BCM by side, angle, side. That's where we finished. Okay, that's where I stopped. I stopped at statement 7. Okay, so I know by corresponding parts that this angle here, AMC, and this angle here, BMC, must be the same because they're corresponding parts of congruent triangles. So your reason 8 is going to be that angle AMC is congruent to angle BMC. Alright, and the reason for that is CPCTC. Now for number 9, we know, okay, first off, angle AMC and BMC are what we call a linear pair. Now they're also congruent, correct? So if they are supplementary and congruent, don't they have to be right angles? So we can say that angle AMC and angle BMC are right angles. And that would be your linear pair equal measure theorem. Oops, forgot my measure here. Measure theorem. Okay? Alright, then, now that we know that they are right angles, we can say that CD is perpendicular to AB because that's the definition of perpendicular lines. Now we've proved that they are perpendicular. Now we need to prove that it's a bisector. So we can say we know that AM is congruent to BM because of CPCTC. We showed that in the last problem. Okay? Which means for me that CD is a bisector. and it bisects AB. And that is the definition of a segment bisector. Oops. So now we have proven that CD not only is perpendicular, but it also bisects AB, and that it's a perpendicular bisector. Okay? So like I said, these proofs are very long and labor intensive. This might be a good time to pause, take a break, and come back and watch the last 5 minutes later. Alright, so hopefully you took a break if needed. If not, let's go right on. What we're doing here is we're trying to prove that angle A and angle D are in fact congruent with our measure, or with our copying. Remember, when you copy an angle, you put your point on A and draw an arc. Do the same from the ray you create. Measure the width of BC and mark it. Connect D to the two arcs intersections, and you have a copied angle. Now, I've told you this is true, but we need to actually state that it is true. So the first thing that you're going to actually do is you're going to draw BC and EF. So what that means here is that I can draw exactly one line through 2 points. Now, we also know that AB, AC, DE, and DF are all the same because I kept my compass measuring the same. Alright, we also know that BC and EF are same measure because we opened our compass to the width of BC and then marked that same arc from point F. So BC and BC and EF are the same measure. So now what I have in actuality is I have two triangles that are congruent by the side-side-side congruence postulate. Okay? So I can actually state that triangle BAC and EDF are congruent. So since the two triangles are congruent by side-side-side, I can say that angle A and angle D are the same measure because of corresponding parts of congruent triangles are congruent. So do you see why we waited to prove these things? You trusted me to say, hey, Miss Norton, I understand that you're going to teach me how to copy an angle correctly, and you're not going to leave me astray. However, you can't, this is no longer the time for you to say, I understand, I get it, I've memorized it. It's not about memorizing it. It's about understanding it. Okay? So the next thing we're going to prove is actually bisecting an angle. Alright, so given our markings, we've got to prove that angle BAD and CAD are in fact the same measure, because that's what it means to bisect an angle. Alright, so we need to draw line BD and DC. And our rationale for that is that there's exactly one line between 2 points, okay? There we go. Not perfect, but I didn't have a straight edge with me. So, step 2. I know that AB is congruent to AC. Well, the reason for that is I made one arc from point A through the angle. So AB and AC have to be the same because of the same compass setting. I also know that BD and CD are the same measure because of the same reason. I also know that AD is congruent to itself by the reflexive property. So I have AB and AC are the same measure, BD and CD are the same measure, and that AD is shared by both triangles. So what I can actually say here is that the two triangles are congruent by side-side-side. So triangle A, BD is congruent to triangle ACD. Alright, so what I can say is that angle ABD is congruent to CAD because of corresponding parts of congruent triangles are congruent. That means that ray AD bisects angle ABD by the definition of an angle bisector. Alright, thanks for pulling through today. I know it was a really tough lesson. You may have to watch it more than once. We will go over some of these questions in class, and we'll do some harder ones in class. Alright, I'll see you then.